And hello everyone. My name is Yoshihiro Tachibana, all the way from Japan. And my talk is very similar to the Jim Oberon's one, and the contribution of the decline in the Chukchi and Bering Sea ice to cold East Asia, along with the cold North America, because here is North America. Anyway, and the okay. And recently, we have published a paper on the influence of the Chukchi Sea reduction on the East Asia and North America. And, I will talk to you about briefly about the process over the ice-free ocean here, and the atmosphere gained a lot of heat from the ocean, so that this area covered with very warm air. And also, the ice-free ocean condition is very, very favorable for the northward intrusion of the very warm and humid air mass into this region, like something like an Atmos River. And so that this area is consistently very warm. And this warm area also influence on the meandering of the jet stream like this. And for that, from this large meandering of jet stream, and very cold Arctic air mass intrude to the Asia and the North America. And also, please look at the ocean process. And this is the vertical profile of ocean in the Pacific side, from south to north. And due to the very strong northward wind stress, the ocean current is accelerated to the north from the Pacific side to the Arctic side. And this means that the very warm and water injects into the Arctic Ocean. And also, the very strong wind stress also strengthens the sea ice retreat to the further north. And they also look at the heat flux, and in the Bering Sea, in the Bering Sea, the heat flux is from atmosphere to ocean, and in the Chukchi Sea region, heat flux is from ocean to atmosphere, so that the atmosphere and ocean, both the atmosphere and ocean, transport the heat from the south to north. That's why this region consistently warm through the winter, so that this kind of very large meandering can repeatedly occur through the winter. So that this is kind of the positive feedback mechanism between the ocean and atmosphere. And I'm sorry. Okay. This map, Jim Oberon already shows that, so I skipped this one. Anyway, and further, we examined the numerical experiment, how the sea ice loss in the Chukchi Sea region influence on the atmospheric circulation. Now, these four figures show the atmospheric numerical simulation. In the case, removing the sea ice in the Bering Chukchi region is removed here. And this one shows the atmospheric response of the removing of the Barents Sea ice region, and C shows the atmospheric response to the removing of the Greenland Hudson Bay region here. And D shows the removal of all of the three regions. So you can see that here you can see the cold Asia and the cold North America and the warm Arctic region. And of course, the amplitude of the removal of all region is much, much larger than this. However, and the Chukchi and Bering Sea ice removal can affect this kind of cold, warm, cold pattern. And next, I will show you. Let's go back to the observation. This A panel shows the upward ocean surface heat flux from ocean to atmosphere. You can see the very large upward heat flux can be seen here, and over the Bering Sea, downward heat flux can be seen. And B and C show the vertical profile of the heating rate, area average heating rate over B show the over the Chukchi Sea, and C show the over the Bering Sea. And using this observational results, we further examine the very simple atmospheric linear balconic model, and adding extra heat over the Chukchi Sea region and removing heat over the Bering Sea region. And we can see the response of the atmosphere. Let's see the results. This is the atmosphere response to the extra heat and extra cooling. So you can see again that the warm Arctic and cold Asia and cold North America too. So that we can confirm that the Bering Chukchi Sea ice removal and reduction of Bering Chukchi Sea area of sea ice remotely influence on the cold and warm and cold pattern. But probably everybody think that the cold winter is influenced by many factors along with the Chukchi and Bering Sea ice region. For example, and Barents Sea ice also influence on the cold winter, and La Nina or El Nino also has an influence on the cold winter. So that the question is that how large contribute the Chukchi Sea ice reduction is a new question. So to solve this problem, we examine as kind of a simple multiple linear regression analysis. So we use these three factors are predictors, and the response, and this is the x1 and x2 and x3, and the response variable, this is a predictive, is we chose the Asian winter temperature of the upper troposphere, and then this is the y. And by using a long-term analysis data set like over 30 years, and we calculate the regression coefficient B1, B2, and B3. And by comparing these three terms, we can understand, we can estimate the contribution of each factors. So that, let's go to the results. And this shows the bit complicated one, and the x-axis shows the chosen very cold winter in Asia. And this is the time, this isn't the time series. And let's see the 2017 case. 2017 means that the winter of 2017 and 18. Anyway, you can see the three bar graphs. And this bar graph, this color shows the contribution of Chukchi Sea ice. And the center, this color shows the contribution of La Nina. And this color shows the contribution of the Barents Sea. So as you can see that all of the three factors positively contribute to the cold winter. However, the most largest one is the Chukchi Sea ice. However, the contribution rate is only 20%. So that this means that many other factors or internal variability of the atmosphere is larger than this external factor. And if we look at the year of 2012, La Nina contribute a lot. And if you look at the 2010, the contribution of the Barents Sea ice reduction is main contributor. And if you look at through the many years, and Barents Sea contribute many times. Anyway, and probably the time is coming, so I'm going to show you the last figure. It's the same figure as I've shown you. And I want to talk to you about the two important things. One thing is that this very large meandering pattern probably occur in the year of La Nina, because the La Nina is very favorable for the northward intrusion of the atmospheric river. Another thing is that is a very important thing is that I would like to say to you that this large meandering pattern would occur more in future than the previous year because the large ice reduction in the Chukchi Sea has just begun recent years. That's my talk. Thank you so much.
Okay. Thank you. Okay. Any questions? Yes. Use the microphone, please.
Thank you for this really interesting talk. I'm actually curious how rare this event
How
rare this event is, because as I see the atmospheric river going straight through the Bering Strait, this is rare. Usually they follow the storm track and actually hit in the Gulf of Alaska, and we could see these events really penetrating Arctic through the Bering Strait rarely. It looks like an outstanding event. I just wonder if you did statistics comparison how that year that you said it was La Nina influence, so it was only one season that you analyzed, how well outstanding it is actually.
Thank you so much. And I think that the case I show you is a very rare case because I think that both the La Nina event and the very small ice area in the Chukchi Sea is very important. And also, even if the La Nina event, La Nina years, and in the beginning of winter, we need to have a large atmospheric river is needed. This is my feeling. That's why every year that never occurs. That in every year, even if the Chukchi Sea reduction occur many years in recent years, however, it doesn't occur every year. This is my talk. This is my feeling.
My question is related to the previous one, is that when you do a principal EOF analysis, for example, you will see that the dominant pattern between the polar and the mid-latitude is in the Barents Sea region, the temperature or sea ice is related to North American temperature, but it's not related to the East Asian. So this must be a rare case, or it's something that is not happen often. Is that true? Or that's my first question. Second one is, in your numerical experiments, you put one warm and one cold heating. So do you know which one is contributing to the East Asia? Is the cold heating or the warm heating? Thank you.
As for the second question, and both are very important. If only heating is added, and this kind of triple pattern never occur. However, if we put only the cooling anomaly added, also triple pattern never occurs. So both and cooling and heating pair is very important for this pattern. And for the first question, I guess that a kind of non-linear process among the Barents Sea ice reduction and Chukchi Sea ice reduction is important. It's my guess.
Thank you very much.
Thank you very much. Thank you so much.
Okay. Is there a question? There actually is a question online.
There was follow on 2018-19 weakening of Arctic front from global warming. We think increased frequency of these events.
What's it?
Do you want to read it?
Yeah.
Or maybe actually it's overlap.
Do you want me to read it for you?
Oh, okay. Yeah. Thank you so much for your question. And today my topic is wintertime mean pattern. However, if you look at the daily variation of the meandering, we can see the similar pattern like I showed you. So this pattern repeatedly occur. However, if it make an annual mean or wintertime mean, this pattern and weakened. That's my feeling. Thank you so much.